welcome back. We're still looking at chemical change, but our focus is on actually saying exactly what happens, to the quantity of, matter when a chemical change or a reaction takes place. Right. Let's look at some of the very important, features or characteristics of a chemical change. In other words, what exactly happens during a chemical change. So we want to, delve into, the finer detail of that and try to break it down so that we understand that at a molecular level, when we say, new substances are formed, what exactly should have happened until that point when we actually get the products, right? Okay, so what are some of these changes that occur in a reaction? Okay, the chemical composition of reaction, there are changes in the chemical composition of the reactants, all right? And also, what is important is that these reactants actually have got some bonds within them. Now, these bonds needs to be broken. So there's breaking of existing bonds in the reactants. And then for us to get new products, there needs to be, some rearrangement of atoms or ions. But remember, if we start with a certain type of, a reactant, in these reactants, what exists are some forces, or bonds that exist between, the particles of these pure substances. So for us to actually get these particles to be rearranged such that at the end we get, new substances, what's supposed to happen is that the existing bonds needs to be broken. So it could be breaking down of atoms of an element, ions of an ionic compounds, it could be also molecules of covalent substances. So the breaking down part is very, very important. However, we also need to note that as we break down, there is also some form of energy that is involved, but we'll talk about that at a later stage. But essentially, the particles of the reacting substances need to be, set free so that they can, combine in different, forms to actually get those new substances. All right. Okay. Then also, here's a simple example of a change that takes place, in a chemical reaction. Suppose we've got hydrogen. Now, if you look at hydrogen, hydrogen is actually a diatomic molecule, right? What do we mean when we say it's a diatomic molecule? Hydrogen, first of all, is an element, okay? Now, we know that elements consist of atoms of the same kind, but in its nature, hydrogen exists as molecules, but it means that these molecules are actually composed of atoms of the same kind joined together. Hence, we talk of molecules of an element. But on the other hand, we also have molecules of what? Of compounds, whereby the atoms are of different elements, okay? Right, so this is a molecule of hydrogen, and if you look at the structure of each molecule, this model actually shows, represents how the hydrogen molecule looks like. So there are two atoms, these are the particles that make up these elements, okay? There are two atoms that are joined together. For us to actually get, the water, which is our product. So these two are our reactants, right? These are our reactants, okay? Now, also, oxygen is a molecule of an element. So the formula O2 suggests that oxygen consists of atoms of the same kind that are joined together. So we need to break these existing bonds so that they can join to form, water, which is our product. So this is our product, right? Also, what is important is that when we talk about the water molecule, now water becomes a molecule of a compound. Now, in this case, we've got H2O, right? So if we are to get this new substance, you'd realize that these existing bonds actually need to be broken. So once that happens, we are able to then get, molecules of water just like that. So this is a new substance. So the physical and chemical properties of this product, which is a new substance, let's refer to it as a new substance, okay? So the physical and chemical properties of this new substance actually differs from that of the reactants, which is the hydrogen molecules and the oxygen molecules. So these are some of the changes that actually occur in a chemical change, right? Okay, what are some of these? That's very important. We are saying that there is formation of new bonds, okay? new bonds are formed. So the existing bonds were first broken, okay, and so that new bonds can be formed. So if we can quickly go back, now the new bonds that we're talking about here, these are the new bonds that we are talking about, okay, that are actually formed, right? So this bond is between the oxygen and hydrogen molecule. These bonds actually didn't exist, in the reactants, but because of, the breaking down of the existing bonds in the reactions, we are able to form these new bonds because these atoms of hydrogen and oxygen are actually able to combine with each other to form our new substance. So in a nutshell, that's actually what happens in as far as this example of a chemical change is concerned, okay? Then ultimately, if we form new bonds, we know that there are new substances which are formed. And what have we, the other term for these new substances is actually the word product, okay? So this is what actually happens, right? Okay, moving along. Now, if we look at an example, okay? Now, we started with hydrogen molecules, okay? Which is a diatomic molecule of an element, okay? There it is. And then we also had oxygen molecules, okay, slightly bigger, okay, right. These are the molecules of oxygen, right, okay. Now, for us to actually get these molecules of water, okay, what is actually happening here, we've got, these are the new bonds that are formed, okay. These are the new bonds. So these are the new bonds that are formed. Now, bonds that are broken, okay, these are formed, and then existing bonds, okay? So existing bonds are actually between particles of the reacting substances, and then new bonds are actually part of the products, okay? Right, so the existing bonds are actually in the reactants, okay? Right, so once these existing bonds are broken, we are able to form new bonds. Okay, this is also another example of existing bonds in the reaction. Now, the bonds between oxygen and hydrogen atoms are the ones that are formed, but we couldn't have been in a position to form these bonds had we not been able to break down these existing bonds. Hence, we talk about the role of energy. But what about these that are between the molecules? So these are forces that keep the molecules of water together. So if we rewind and go back, we also want to think about, the physical properties of different, phases of matter. In a solid, we talk about, particles being closely packed together, and then we're saying that the reason why they are closely packed together is because of the forces that exist between the molecules, okay? So these are actually intermolecular forces. So these are forces between molecules, okay? So these are the forces between the molecules, okay, of a product, okay? So we need to be able to distinguish between forces between the particles of a substance and forces between the molecules, okay? So as a result, we are able to say, okay, this is what exactly has happened in as far as the chemical change is concerned. Okay, what are some of the changes that also occur that we want to look into? Okay, the initial number of atoms, okay, remains the same as the number of atoms in the product. Look, we can also use everyday life examples. So if you are to bake something, the ingredients, you want to think of them as the reactants, okay? Because once there's formation of new substances, then we know that type of a change is a chemical change or simply a chemical reaction. So the amount of, the cakes that you get is actually related to the amount of ingredients, So if you use a 500 gram sample of flour, for argument's sake, there is no way possible that you can get a drum full of, cakes. So as a result, whatever you put in needs to be exactly more or less equal to what you get out. So the number of atoms is, you think of them as the particles that make up a substance, is also going to affect the quantity of the products that you get. So the big question that we asked ourselves in the first segment is that what exactly happens to the quantity of matter when a chemical change does take place? So by all means, we want to think that, okay, so if the quantity, we've got X amount of reactants in terms of quantity, we need to get plus minus X amount of quantity of the product. So there is a link between amount of reactants and the amount of substance. So the statement says the number of atoms of the reactants is actually equal to the number of atoms of the products. Okay, right, that's the main idea. And then the number of molecules may change. So there are two things here. We've got atoms and then we've got molecules. Okay. What is important in a chemical change is that, when we break down, bonds that exist between the particles of the reactants, these atoms are now free to be rearranged to form new substances. So the number of atoms may not necessarily be equal to the number of molecules. We shall use a simulation to try and put that into context. Right, okay? And then here is a perfect example that we've managed to look at. If you look at the number of atoms on the left-hand side, in as far as hydrogen as an element is concerned, we would realize that here there's 4 atoms. Okay, there's 4 atoms. Okay, but in these 4 atoms, it's actually 2 molecules. Okay, of hydrogen, while as far as oxygen is concerned, we've got 2 atoms, okay? But we know that oxygen actually exists as a diatomic molecule of an element. So there is actually 1 molecule here, okay? There's actually 1 molecule. But if you look at the product side, this is a molecule of water. That's another molecule of water. Okay, and the formula, chemical formula, is H2O. So that's a molecule of water. How many molecules do we have here? The molecules, there are actually 2. Okay, molecules. Okay. So in as far as this new substance is concerned, there's only 2 molecules. You can check on the left-hand side. There's a total of 3 molecules. Okay. So there's a total of 3 molecules, while on the right-hand side, there's 2 molecules. Okay. There is a reason why the number of molecules does not necessarily remain the same, because these substances, they actually react with each other in fixed ratios. Okay, so if we go back to that statement, it says if the initial number of atoms does remain the same. Is that true? Yes. On the left, we've got 4 atoms of hydrogen and 4 atoms of hydrogen on the right-hand side, while on the left-hand side, 2 atoms of oxygen, 2 atoms. But the number of molecules does not necessarily remain constant, right? So in a chemical change, existing forces or bonds are broken between the particles of the reacting substances. And to break bonds, we spoke about the energy being absorbed, okay? When atoms are rearranged, then new substances are actually formed. So the release of energy only happens when new bonds are formed. But when bonds are broken, energy is absorbed. That's the main idea in as far as that. But the molecular size changes, okay, not of the individual atoms. You had seen the example with the water molecules. And then also the shape of molecules changed. We had hydrogen and oxygen, okay, but then we've got, at the end of the day, what? So the shape does change in a chemical reaction. But the number of molecules, not the individual atoms, will also change, right? Okay. Now, that's as far as, the changes are concerned. Okay, we'll end it there for now and then take a short break. See you after the break.